So here's our starter question for task 2. And I'm going to go through this in quite a bit of depth and turn it into our first example as we go. But I think this is a really important thing to pick out with you because it is a kind of really relevant idea to lots of stuff that's going on at the moment. And actually, it explains quite a lot of patterns which are a bit counterintuitive. It's almost paradoxical, this question. And we're going to kind of explain why. Because I think if you gave this to the average member of the public, does the long-term outcome change the starting number of ill people change? Yeah, you probably get the right answer to that one. But what do we expect to happen long-term? If you tell people that 19% of people that are ill are getting healthy and only 1% are getting ill, most people intuitively would say, wow, okay, the number of ill people is going to go down really quickly. And actually, that is not what we see happening in this situation, as you have probably discovered by calculating the numbers. So let's make a little table. Here we are counting days, and then we're counting the number of healthy people, and we're counting the number of unhealthy people. And let's just quickly sketch that table. So on day 0, we are told that we have 30,000 people. 30,000 people who are unhealthy, and everyone else is healthy. Now, if we do that, 5 million, take away our 30,000, leaves us with 4,970,000. So that is the number of healthy people that we have. On day 1, we've got a little bit more of a complicated calculation to do. So let's, I could use a ruler for drawing a table. That would be excellent, wouldn't it? So on this next day, let's look at our unhealthy people first, and then we'll figure out how many healthy ones there are by doing 5 million, take this away. So our unhealthy people, well, 19% of them have got better, which means 81% of them, or 0.81 of them, are still ill. So of these 30,000, 81% are still ill. And then we also have 1% of these guys who are healthy, which is 4,970,000, who are becoming ill. So there's our people who are remaining ill, and there's our people who are becoming ill. Add those together, we get, and I think it is 74,000 people that now comes to. Now, as I say, healthy is easy to calculate because it's the rest of the people who must be healthy. So 5 million, take away this number, which is 4,926,000. So after day 1, our number of unhealthy people is actually increased. Now, day 2, something not dissimilar in terms of calculation. 81% of the people who were ill yesterday, that's this 74,000 number, are still ill. And 1% of the healthy people, which is this 4,926,000, have become ill. We can work that out. We are now at 109,200. Take that away from our 5 million, and we can fill in this box 4890800. Now, let's do one more. I don't want to spend the whole video doing this because I do want to get to the point, but one more will kind of help to give us a feel for this. If we take this and we do 0.81 times our 109,200 plus 0.01 times 4890800, then we can work out our ill people, which is now 137,360. And taking that away, our healthy people is now 486,2640. So, what's going on long term? Well, it's hard to tell. At the moment, the number of unhealthy people is actually increasing. As I say, it's a little bit paradoxical, but let's think why it's happening. It's because although 19% are getting better, that's only 19% of this number, which is a small number, relatively speaking. But the 1% of the whole population is a really big number, because 1% of 5 million-ish, or 4,970,000, is a really big number. So although we've got a high percentage of the ill people getting well, even 1% of the whole population getting ill means our number of unhealthy people or ill people is growing quite fast. But what's going to happen over time? Well, as more and more people get ill, this recovery rate will start to have an impact. And the number of people that are healthy that could get ill is actually decreasing over time. Now, that might sound a little bit familiar, and actually, I'm going to sketch the graph of what happens, because this is a really important kind of relationship to start seeing. So at the start, our number of ill people is growing really fast, but as our number of ill people grows, it actually begins to flatten out. And at some point, it will reach a limit. Now, in the case of this particular situation, you can calculate it, and we will do that in a moment. You will find we actually start to level out at 250,000 people. So although it's growing really fast initially, when we get to 250,000 people, doing 81% of 250,000 plus 1% of the remaining 4,750,000 leaves you statically at 250,000. Now, you might well have spotted that there are some quite good applications to our current situation with the pandemic. And that's not accidental. I've picked this because it's really, really applicable to where we're at. That even if the number of people getting ill is quite small, so long as your recovery rate isn't very high, the number will plateau at some rate of people getting ill. Now, I've kind of exaggerated the numbers here to make it a little bit extreme, but the principle of exactly the situation we're in is right here. There will become a plateau where people stop getting ill. Now, that isn't to say there aren't two things that we can do about this situation. The first thing that we can do about the situation is reduce the number of healthy people who could get ill. So instead of having healthy people who could get ill being the whole population, if you start vaccinating, or you've got people who've had, say in this case of the current pandemic, coronavirus already, this number of healthy people who could get ill actually reduces. So that helps limit this problem here of our continually increasing growth rate. It might increase and plateau, but you can bring where it plateaus to a much, much lower level. The second thing you can do is improve the recovery rate. So if 100% people recover every week, there is no problem, because even 1% getting ill, it'll plateau out at 1% of the whole population being ill at any given time. It won't grow. So we can improve recovery. And the other thing you can do is put in lockdowns and social distancing, which makes this percentage of people getting ill really, really small. Now, I hope that's interesting and applies to where we currently are as a population and why some of the measures you're seeing in place are being put in place, because those are the three strategies you can do to combat the level at which this number here plateaus out. Now, in the next video, I'm going to show you the actual maths that got me to 250,000, but hopefully that gives you a little bit of inspiration about why this is a really interesting situation to study. Even in a really simple model like the one we set up, we can generate really realistic effects.